This session, we're actually going to do a little bit deep dive about something you saw in Don's keynote yesterday. But we're going to expand the subject a little bit. And the topic is triage patient portal messages using ChatGPT technology to automate workflow. There are three presenters. I'll kick it off. I'm a physician executive in the healthcare team. All of you should know Don Woodlock right now, and he will present next. He's a VP of healthcare. And Meredith Staszak is the product manager for patient experience. So I'll just quickly give you a background why we are doing this. I think this is very important. You probably saw in the news late last year, Epic, and basically the Cleveland Clinic uses Epic, and also MyChart for patient portal. They started charging patients for medical-related messages. These messages could be related to I'm changing in my medical conditions, I'm changing in my medications, changing with the situation that requires some additional forms and so on and so forth. So it was deemed as requiring the clinician to spend a little bit more time to process those and respond to the patient, but also do some clinical tasks. So they decided to charge. And for the private insurers, the charge is between $33 per message to $50 per messages. And so it's not a small amount, but Cleveland Clinic thought this is taking clinician time, it's a clinical task, they should do it. Another information, this is also very important, is the volume, the sheer volume. So there have been reports, I'm using some of the reports, it was from Wall Street Journal that looked at quite a few the papers that was published, and this paper quoted something from UC San Diego. So before pandemic, the entire organization has about 50,000 messages per month, and after pandemic is 80,000 messages a month. And during pandemic, at one point, it was 140,000 messages per month. We have similar statistics from other institutions. And recently, University of Colorado talked about they have over 400 physicians that has 5,000 messages in their in basket. Just tons of messages for the clinician to go through and related to patient portals. Why is it important? Because a lot of messages takes time for the clinician to process. This is from a study that was looking at all the messages it was looking at about 366 health systems that use Epic, and they look at the time between December 2019 and December 2020. Every message on average requires additional 2.3 minutes per message for the clinicians to go into the EHR, to conduct tasks, and to really take care of the messages. So the volume is fairly high, it's time consuming, and it's just very important. But of course we want to serve the patient, we want to respond to them, the messages. Now, why does it also matter? The clinician's well-being are linked to these inbox messages. They're generated by algorithm. This is what it means is that it's not just about the patient portal messages. The EHR also generate lots of messages. This is a paper that was published in Health Affairs, and looking at Palo Alto Medical Foundation, and looking at all the messages and understanding what are those messages, where are they coming from. And the patient portal messages was about the 15%, half of the messages were generated by the EHRs. So it is overwhelming from a clinician's point of view, and their well-being also suffer. So here's where we're going to talk about some of the project. Earlier in the keynote, you probably heard about Bay State Health. They are a regional health system, Western Massachusetts, 5 hospitals, taking care of about 800,000 patients. They use our patient portal as a primary way to engage the patient. Patient will send a lot of messages, naturally. And they're triaged by this central contact center team, and before it goes to the clinicians. And as you'll see, some of the workflow is actually how to enhance the central contact center. It's about 1,000 messages a day. They classify all these messages. General questions or medical questions is about half of those messages. So the contact center, they have to go through them, they forward them, and so there's a lot of process that's in place. So now we're going to switch gear and have Don to talk about what we're doing with it.
Great. Okay. All right, so I'll go into a little bit more depth on how the model is trained and how we validate it for this particular customer. I'm mainly focusing on the urgency use case, so automatically reading a message and determining whether it's urgent or not. So the first thing I wanted to mention is how these large language models are trained and what some of the terminology is. And there are actually 3 opportunities for training. So one is pre-training. So these, the models are initially trained, I put on computers that you can't afford. So they asked, like the CEO of OpenAI, how much, I think the question was, did it cost, I heard it cost more than $100 million to train GPT-4. And he said, more than that. So these things are sort of trained on massive computers, and you get them pre-trained. That's what you use. The analogy I would say, I'm sure you'll be tired of music analogies by the time I'm finished, but the analogy I would say, it's kind of like a piano player that has been playing scales for years. You know, they don't know the song that you're kind of asking to play yet, but they know how to do scales and exercises and those sorts of things. And then when you give it a song, it only takes a little bit of time to adjust to that song. So the scales, in this case, they train these models on just language tasks from like all of Wikipedia or all the internet. And some of the language tasks are they randomly mask 15% of the words in a sentence and train the model to be able to guess the missing words. Or they'll take 2 random sentences and ask if these sentences are consecutive with each other in normal text. So things like that. So it gets a feel for what words are similar to each other, like a big and large, would be used commonly in similar contexts. They get a feel for the flow of language, like which points are after other points, that sort of thing. So this pre-training kind of teaches these models about language. And then the next step is fine-tuning. So, and sometimes you do this. We did this with urgency. So fine-tuning was the case that we did, where we took 1,000 messages that were labeled whether they were urgent or not. We used one of these pre-trained models, and we fine-tuned it. So this is like giving that piano player the final piece. So before this, it doesn't know what an urgent message is. It knows the word urgent. It knows how people express things. But now you're really training it on the urgency task. And then lastly, there's a kind of a final training opportunity, at least with something like ChatGPT, which I call the prompt before the prompt. So if you saw my demo, for instance, yesterday, and I typed the question, what were her past admissions? What were the patient's past admissions? What actually got sent to ChatGPT was a much larger question. It was, given this patient medical record, and then we had a dump of the medical record, answer this question, what were her past admissions? So that stuff was the prompt before the prompt. The other example I used yesterday were in the analytics, like what are my top 3 diagnoses? So we didn't actually send just that to ChatGPT. We had a context above, which is say, I'm about to ask you to write a SQL query. These are the main tables in my database. Here's how to join the tables together. Please write me a SQL query that answers the following question, and then we'd pass along the prompt. Okay? So you can actually use that to do a few examples. Like, I want you to classify this message for urgency. Here are a couple examples of urgent messages, that sort of thing. So that's why this new field of prompt engineering is coming out. So there's some science behind really leveraging these language models in this kind of prompt before the prompt area. Okay? So what I'm going to use the word training, but what we technically did in this urgency models, we fine-tuned the model to a big language model. We fine-tuned it to know about the urgent task. Okay, so here's how we did it. So Baystate had a definition of urgency. And they had and this was the definition that they used for their call center staff. So when patients call in, they said, if you hear anything on the left, hang up and tell them to go to the ED. Okay, so that they called their red list. And then on the right, they said, if you hear anything on the right, warmly transfer the call to a nurse. Okay, so that was kind of their 2 definitions of urgence, which we lumped together for this project. So we took a definition of urgency, And then we took 1,000 messages, which were one day of Bay State's messages, and we labeled them. So we had a team of 5 clinicians, including Chi. They spent 3 hours together, read every message, and labeled it as urgent or not according to that definition. Okay? So the way it turned out is one of those messages was 911 urgent, and 35 were warm transfer urgent. So we just went with the 36. So 3.6% of messages were urgent. Okay? So now the next task is to train this machine learning model to automatically find these 36, in a sense. Okay? So the first question Bay State asked is, why do we need ML? Why don't we just do string searches? Okay? Why don't we take extremely ill, fever 103, unconscious, rapid heart rate? Why don't we just string search our way through that? And I think that's a great question, because you have to justify the use of ML by having it be better than a simple, understandable method. Okay? So the first thing we did was we wrote a string search algorithm based on those words and said, well, how many of those 36 messages can string search find? This is a confusion matrix. This is a little confusing. Maybe that's why they call it this, actually. But what this is that you can see the actual values, meaning there were 36 urgent messages. That's how the rows work, and 964 non-urgent. And this is what string search predicted. So string search thought 21 of these messages were urgent, but only 6 of them were actually urgent. So that's what this cell means. And it thought 979 were not urgent, but essentially it missed 30 urgent messages. Okay? So the main stats that we used were recall, which is the ability to find the urgent messages. It only found 6 of the 36. So that's what that recall number is, 16%. And then when you do make a guess, what percentage of the time are you right? So you made 21 guesses, only 6 times you were right, so your precision is 28%. That's how those two metrics work. Okay, so not great that you can just find 6 of these messages. So now we trained machine learning models, and we'll compare it in a moment to that string search. These were, for this project, a few projects that Meredith will show, we did use the ChatGPT model, but for this one, we just downloaded a local model, this BERT model, and then there's one trained on medical notes, BioBERT, and essentially used that pre-trained model, fine-tuned it for urgency. We got to 93%. It's actually, I'm not going to explain this metric too much because we don't have too much time. But the accuracy is not a very good metric for a needle in a haystack problem. So since there's only 3.6% of urgent messages, does anybody know how you would build a model that is 96% accurate? Yeah, say everything is not urgent. So this is a better metric to do that. It doesn't allow you it doesn't count the easy cell. But I use the word accuracy anyway. So this ended up being 93% accurate, and I'll show you how that works. So the model itself doesn't necessarily predict urgent or non-urgent. It predicts the probability of being urgent. Okay? And then you decide where you want to put the cut line, the threshold. And this is a decision with you and the business leaders, essentially. If you put the cut line way up top, you're going to predict a few urgents, but when you predict, you're going to be right. Okay? But you're not going to find a lot of urgents. If you put the line way down, you're going to find all your urgents, but you're also going to have a lot of false positives. So you're kind of going to bother people. So it's kind of a balance between finding everything or finding enough of them and not bogging down with too many false positives. So what that essentially means, because there's a lot of cut lines, is that there's a lot of confusion matrices. So in this case, this is the cut line. This is the threshold percent. So let's say you only picked things that had a 40% probability of being urgent. That would mean you'd find 8 of the 36, but you would only make 22 guesses in finding that 8. So you'd have a recall of that number and a precision of that number. So that's actually the most equivalent to the string search. The string search only guessed 21, so I took kind of the top 21 items there, and it found 8 instead of the 6 for string search. But you can always lower the threshold. So in this case, if you lower the threshold to 1% chance of being urgent, you'll find 35 of the 36 urgents, and you'll have made 499 guesses. Which the way Baystate looked at this, they said, with the exception of that one that's missed, you cut my workload in half, in a sense. We still have to read everything, but if we can take the 1,000 and make it just 500 that we read during the day, we're basically going to find all our urgents. Okay? So that's one way to look at it. But essentially the way to do it is you can order your entire work list from most urgent to least urgent and just sort of work that in order. So, so this is the comparison to string search. If you take about the same you take the exact same number of guesses, the 21 are urgent. If you force this model to just look at the top 21 rows, it identifies 8 of the urgent instead of 6. So it doesn't sound that much better, but it is 2 divided by 6 better. Okay? The other flexible thing about machine learning is you can keep moving that line down. With string search, you can't really. So you keep moving that line down to find more items. So the second question that I wanted to answer is, well, is this as good as a human? And a lot of machine learning models are very black and white. Like if you train a model to identify a cat versus a dog, there's common agreement which is a cat and which is a dog. Now, there's not common agreement about what is urgent and what is not urgent among 2 different people. So it's a different kind of model. So what we did is this team of 5 is the team that I mentioned before. They were the ones that selected those 36 of the 1,000. I found a different physician at InterSystems, and I said, you go label the 1,000. Don't talk to anybody else. You go label the 1,000. And then the machine learning model has done its work. So the physician thought 12 of these 1,000 were urgent, only 12, and only got 4 of them right. Didn't take that many guesses, but only got 4 of them right. If you restrict the machine learning model to also only guess 12, it finds 5 of the 8. So to me, this machine learning model is this performance is comparable to another person sort of reading urgent messages. Okay? There's more validation to do, as we get this into testing and production and that sort of thing. But I think that this machine learning model is on the order of what another person would think if they read a group of messages in terms of what's urgent or not. Okay? So that's another way to think of that kind of 93% accuracy in this case. Okay, so that's a little bit more about how how the under the covers sort of training and how we validated and thought about its accuracy. And then Meredith will show you what this looks like. Okay? Yep.
Great, thanks, Don. So obviously the next step, once we have the model that we know and trust, is to actually put it into a workflow. So my title is patient experience. Everything that we're looking at here is benefiting more user experience. So everything that we're trying to do, while it stemmed from bettering the lives of people completing the tasks, has an indirect effect on the patients themselves. Because if it was an urgent message that I sent in, I'm going to get reprioritized, I'm answered faster, and some of the other use cases that we looked at will come into play as well. So we started really, as Don was saying, the urgent message management use case that I've listed second for some reason is the one that we've been moving forward with Baystate. Around that, we've actually been playing around with 3 different additional use cases. So continuing to use the model that we had this navigation assistance prompt as well. So we found while we were analyzing Baystate's data, or they found in their initial assessment, I believe, that a lot of folks were using messaging to accomplish other actions they could have been doing themselves in the portal. So can you help me book this appointment instead of actually going to the appointment section of the application? So we wanted to do something similar with the model to redirect the patient to actually prevent them from sending the workflow. And so that uses the same model that Don was talking about. And then being the 3 of us, we kept going. So then we got really excited about ChatGPT, and we're like, well, what can we do next? In our conversations, Baystate kept reiterating, they have to open every message. So they open every single message to see who is best to answer it, what the content is, how they move forward. So we hooked it up to ChatGPT for 2 additional scenarios. The first is simply to summarize the message. So instead of having to open each message and see what it's about, we asked for a 2 to 3 word prompt and immediately stuck that on the queue as well. So now I can take a look at it and just see right away what's happening. And then, because we just like to keep going, how well does ChatGPT come up with an answer for me? So if we give it the message and say, can we get a response, what does that look like? And so I do want to talk just architecturally about this. So we are discussing very specifically, and I'll demo using personal community. So that is our standard patient-facing application. But we can abstract this to really whatever set of applications you're using. So in this case, you have a patient-facing application or your engagement app where your patient is actually entering their message. And then you have some sort of messaging work list. That's where it ends up at the end for somebody to process. In the middle of this, you have your interoperability engine that's doing some level of processing. So the message will come in, we decide where it needs to go, and we go ahead and shoot it back off to the work list to an appropriate set of people. So what we basically did was hijack this normal processing that's occurring to make the call out to a Python application to do this initial sort of analysis. So now before I get the message ready to deliver to my work list, we simply take the subject and the text of the message, have it analyzed, and come back. If it hits that desired threshold, we manipulate it, and I'll show you the manipulations in a bit. And so that really covers kind of the 3 use cases I had on the right. For the 4th one, we're intercepting earlier. So instead of even entering our messaging workflow, we're taking that desired subject and text that the patient entered, passing it in through an analysis. This is your standard ensemble and interoperability pieces to the same operation over through the Python app, which is calling ChatGPT to do some of the initial redirection if we want. And now, everybody hold your breath because I'm going to hit the button. And please. OK.
Something's up.
Nobody touch the table. It's going to work. It's going to work. OK. So to kind of illustrate the various points, we'll start with the navigation assistance one. So in this case, I just jumped to the end where I took you to appointments. Sorry about that. Wrong demo. OK. So in all cases, I'm just going to show a medical questions that they're going to be sent through, and everything is going to go to that call center. Nope. And of course, my copy and paste didn't work because this is the day we're having. Hold 1 second, please. All right. So we've got a message from the patient, very clearly that they want assistance booking some sort of appointment. And so instead of generating that message, we hit a response threshold saying, hey, we think you actually want to book an appointment, sending the redirect back to the patient. Because I'm a nice person for my patients, I do let them continue to send the message should they really want to talk to you. Otherwise, they can just go ahead and click the book the appointment. The message is never sent. So we're now removing a whole set of messages from somebody's work list, and the patient's able to learn that there are additional things that they can do within this application on their own. So it's a little bit of education for the patient as well as alleviating workload here. And from a patient perspective, now I just booked my appointment and I'm done now, instead of waiting for days to come back. So that's kind of cool. If we move into the specific urgency one that we were talking about, let me get Melanie here. Command, copy. We'll go ahead and send a message that should flag as urgent. All right, so we have something that, seems decently urgent, high temp, aches all over, and we go ahead and we send it. So there's a couple things that I did here. This is just bonus fun where I was playing around with perhaps giving a different message to the patient. So we did send their message, but we did a little bit of a visualization back to give them maybe an additional prompt that maybe you should contact the call center. And then we went ahead and sent that message through. So again, taking now the subject and text of that message and typing it in correctly this time, taking a look at the task list that was generated. And so, I don't know if you all read the system, but the first thing that comes up here is that we actually see the message that we just played through, top of my queue, and flagged as urgent. So we made a couple adjustments to this work list. And so we're doing a very similar thing with Baystate in their actual Cerner messaging interface, where the first thing we did is we labeled it as urgent. So any message that made that threshold now has a yes in the urgency column. And we also reprioritize the way that we present the tasks. So they're all pulled up to the top, showing you the most urgent messages first. In addition to that, what we've got is kind of this concept of different work groups. So not only could we just simply add a label to it, we could actually redirect it. So I did say everything was going to the call center. I've also created this urgent call center. And in this case, if I switch to filter by just the urgent call center, we'll see now that these were actually sent to a separate work list. So we have the option of simply reprioritizing an urgent message and making that available in the general work list itself, or we could actually redirect it to a more elite group of people to answer. So that's kind of fun. Let's move on to my final one, and we'll talk through some of the other things. So when we start looking at the ChatGPT pieces, we wanted to see kind of how it responded and how it did the summarization. So I picked something a little bit more different to talk about. So let's say that on my way here, I have a fear of flying. So I wanted to see if I could get any sort of assistance before I took this flight. So something a little bit different, not going to be urgent. Again, we're taking these, sending it through. You can see the more simple message for the patient saying that it was sent. And what we should see, if this all worked for me, now, hold on. Let me just sign out and back in while it's possibly still processing that one. All right, so again, everything now is kind of passed through. We should have the latest message we have. So interesting, we see a few new things about it. So it's not an urgent message, so we've got it now in the second piece of the information. And I'll start drawing your attention to the additional column here that said summarization. So we asked ChatGPT to summarize the message, and in this case, it came up with request prescription. So it's not bad. I did ask for medications or things that you could do while I'm flying. And so this summary thing gives us actually a different way to handle the list as well. So before we look at the results of that, another way that we can think of using that summarization is around reassigning the actual tasks. So if we're talking thousands coming in a day, maybe I have people that are better suited to answer specific questions. So I can actually now use that summary to start saying, well, okay, everything related to, let's say, a new patient or a referral, I can find very quickly in this list and assign directly to somebody's queue so that the second they come in the morning, they can start answering them, which is kind of neat as well. And then to take it all the way to the end, if we go ahead and look at what the analysis gave us for how to respond to this patient. All right. So I said that I was very anxious about this flight and was wondering if I could have anything that could be prescribed to me. So prescription request actually was a pretty good thing for that. And if I can expand this out, let's see how we responded. I get a lovely full set of information back from ChatGPT around how to respond here. So I said I was nervous. It is very nice to me. It understands that I'm going to be taking a flight. I have concerns. It's validating my feelings, which I thought was kind of fun. It's making me feel better about myself. Before moving into what I actually kind of asked it for was what could it offer me? So giving me some options for prescriptions, and then saying that, maybe I actually do need to kind of follow up. And then this is slightly different than the last one. I do enjoy that it is now telling me other ways to manage my anxiety around reading a book, using a blanket, and feeling comfortable. That's the first time actually I've seen it respond that way to me. So I've looked at probably, 50 to 75 of these now, and it's a very common way that it's responding, where it is actually validating feelings, answering your question, and then giving you some sort of summarization. So I thought it was pretty interesting the way it responded. The way we have this coming in is a proposed response, so I could opt to, as the user here, take out all of this, redirect it however we want, answer it however way I want, and the intent was kind of to just give a suggestion for how we might want to respond. And so that's really the 4 use cases we took on. So I think, am I back to you?
Oh, perfect. Excellent. So I forgot to poll the audience. Do any of you see overwhelming number of patient messages in your institution? Yes. Our friends at the UC Davis. Definitely. That's a large health system. Actually, some of the study was from the UC healthcare system. In a very early adopter of EHR technologies and really just helping the patient, clearly they're seeing lots of value. And of course, you must be wondering, what else can ChatGPT do? And interesting thing I just want to mention is that for one, I would love to this auto response thing, and just so that I can communicate with my family better. Just make me sound more empathetic. If you remember, Don talked about ChatGPT response is 10 times more likely than the actual doctor's response, and certainly that's very helpful. But sometimes you wonder, are there more things that it can do, right? So to answer that, we actually turn to ChatGPT. I'm sure there's some hallucination there, which is a technical term. They are making something up. I hope it's not the case, because a lot of stuff is actually fairly meaningful. Interestingly, before I just talk about it, I would say there have been lots of doctors researching about what ChatGPT can do. There are clinical side of things, and we're not talking about ChatGPT replacing doctor. As you can see, the first use case base they came to us was around how to improve operations. So here are some examples. So this was a doctor decide to ask ChatGPT. I decided to do screenshots instead of a summary. This is a verbatim from the ChatGPT response, just to show, there's nothing was interpreted, commented by me. So the question was, what are the big opportunities for using ChatGPT in healthcare? So that's the answer, right? You can see there's a virtual assistant for patient care. And there's clinical documentation, and you probably haven't seen that there's lots of clinical notes needs to be created by the clinicians. It's time consuming. They want to do a good job creating the notes and to share with other clinicians, so on and so forth. And but there's also medical research. It can summarize the information. There's overwhelming amount of new literature findings, new papers, and try to go through that. We used to have journal club, just so that not everybody has to read through everything. So somebody's assigned, usually as a junior clinicians, to read all of that and then report to the group. So now you can do tons of stuff to summarize medical research. And so there's very much things that you can do to help doctor become a better doctor. And then there's medical education in the training aspects of it. And instead of just getting yelled at by the attending all the time, maybe there are things we can do a little bit more empathetically towards the medical students. In the patient engagement, you earlier saw that, all the patient messages, so on and so forth. So we definitely see there are places we can start by improving the patient experience, by improving the most critical people really at the front line at the health system, dealing with the patient, make their process more efficient, more automated, things that doesn't need to go through them can go directly to the practice. In all this, I think ChatGPT could make tremendous input before they replace any doctors. So I just want to give you this positive note. This is not what we're trying to say, ChatGPT will replace doctors. And with that, I'll just thank you. And if you want to contact us and for any questions. And now, right now, we also have time for questions and comments. Yes?
So the confusion that before regarding machine learning and regarding also phrases. You have also this confusion that is because we ask ChatGPT.
Sorry, I thought you were asking a slightly different question. Let me answer the question I thought you were asking, then I'll come back to that. So we did not do accuracy testing of the summarization, summarize in 2 words, or the propose a response. So, so we'll start to validate that with the customer and others, whether they kind of agree with these sorts of things.
I was asking regarding the emergence. Usually,
Yes.
is urgent or not?
So he's trying to explain that can we improve the model of accuracy by implementing ChatGPT, like embedded in ChatGPT, and then based on that, it can improve the accuracy model.
So,
Urgent, not urgent.
yeah. So, so I use a machine learning approach on top of a large language model. This was a large language model that wasn't GPT, but was like GPT. It was this model called BioBERT. So I could try to do it with GPT 3.5 or 4, but I haven't done that yet. The problem with ChatGPT at the moment is that you're sending PHI to OpenAI, which you can't do. So Azure now has an offering where they'll privately host OpenAI's models, and you could send it there, and it won't be shared or used in product training days. So I haven't done that yet. We use that for the other demo. BioBERT. It's called BioBERT. Yes. Yes, correct, yeah. And I think, so the urgency model is not generating text. It's really just labeling something as urgent or not urgent. For that, you don't need a super expensive model. Of course, the other thing is every time you call ChatGPT, you pay like a dime. So you're going to want to use the right tool for the job. And the urgency, I don't think, was as complicated enough to justify the cost. It's better than XGBoost. So I did, yes. So see that traditional, well, Cat Boost. So I used another gradient boosting, and it was better than all those. So I did the traditional machine learning first around XGBoost, and large language models were better. Yeah. You can also combine them. So not to get too technical, so the output of a large language model is it takes a message and it returns a float, a vector of numbers. And then you could take that as if these are features, and then you could take that vector and then train XGBoost on the back of it, which I tried, but large language by itself is better. Yeah. Other questions? Yeah.
If there's conflicting information in the message, say on an appointment because a shark hit me, ripped my leg off on the weekend, does the urgency outweigh the appointment, or was there going to pop up for the appointment?
So they're separate models. So there's one model that's the probability of this message being urgent, and a separate model on the probability that this message being about an appointment, because those are orthogonal concepts. So you'd get 2 probabilities, and then you'd have to work with your business users. How would you like to prioritize? Or have 2 columns, or something like that. So that's a separate training action.
I like the way it categorized, that this is a medication refill. Mm-hmm. But often patients put in 5 different things that they want in one email.
Yes.
How would you tackle that?
Yes.
Would they have multiple lists they would come up in? Or?
Well, it depends on how you label. So before training, you're going to label your data. So you can decide to have multiple labels that this, just like the urgent and appointment was multiple labels. So let's say, so you can basically decide to have multiple labels or some single, like the patient is talking about medication, they're talking about a refill, or they're talking about multiple issues. You know, it's like a race or ethnicity question. You know, you can ask single races, and one of the answers might be multi-race or something like that. So you can kind of decide how you want to label the data. Then you train the model, and then the model will just do what you said. If that makes sense.
So my question is there any plan for having other languages than English, like Arabic?
Sure, sure.
And it's going to follow the same.
It would follow the same process. Yeah, yeah. So not for Bay State, unless they have a.
They do have a Spanish-speaking population.
Okay.
We just haven't gotten into that yet. I think
So
it's English to start.
most of the infrastructure is unchanged, especially if you can get the large language model in that language. The rest of the infrastructure is basically unchanged. You'll have to label a set of messages unless you believe auto-translation of those messages, and then use that to train the model in the exact same way.
And then another question, I'm not so sure, maybe it's answered before. What if the information was not found? So for example, there was one missing word that was a keyword that was not there. How would the system react, or how would the AI react in this regard? Does it shoot a message to someone saying that I could not find any information, or how does it look like?
If for the purpose of labeling it as urgent or not? Yeah, it'll still make it into somebody's work list. The issue is, you know, patients don't speak clearly either. You know, so there's imperfections all around. Even as humans reading a message, you can't tell exactly what this patient is saying. So it's going to do similarly their best, or its best, you know, to do the work.
And is there any plan of improving? So it's actually one of the questions that I had earlier. For how long has this study been done, or how long this started, and then what's the plan going forward?
So this project has been in place for
A couple months?
4 months, let's
Yeah.
say. 4 months.
I would assume that the improvement would happen maybe after 1 year because you would get more information.
Yeah. One of the burdens of machine learning is labeling the data, so doing this 1,000 things. But if you can automatically label the data, so for instance, if it comes into the work list and then they call the patient, and then they mark on the work list, I called the patient. That would be training data that's generated all day long for you to develop a model that says, is this a message that's going to lead to a phone call? So one of the things you can do is look at the user workflow and see, is it the actions that are recorded, did they forward it? Did they call the patient? Did they close it? If you can get a hold of those actions, then you could train the model every day. Actually, you can kind of automatically train it based on the resulting action, predicting the resulting action. So one of the things that they really want to do is auto-forward messages that they forward as humans. So if we can watch the forwarding and train a model based on it, we can get pretty accurate on auto-forwarding. So I know we're running way over. Is that true? Oh, yeah,
There's no break. We should.
I know, but now we're in the second session. But, okay, one more question. How about, yeah. Yeah, okay, a double.
You have to do some reprocessing in the text in order to achieve these results?
No.
Correct. The second, did you try integrating that in the traditional machine learning?
We did not, actually. Integrated ML would be similar to the performance of number one, I think, because you're not leveraging a language model for that, which is pretty good given the integrated ML is a small amount of work. You know, that's really the benefit of that approach. Yeah. Okay, thank you very much.
Thank you.
Yeah.